Hello students, welcome to Engineers Academy. Today we are having another physics problem at hand and we are going to solve that. And the problem says that the position of a particle moving along the x-axis is given in centimeters by this x of t function where t is in seconds. Calculate the average velocity during the time interval t from t equals to 2 seconds to t equals to 3 seconds. The instantaneous velocity at t equals to 2 seconds, 3 seconds, and the instantaneous velocity at t equals to 2.5 seconds, and the instantaneous velocity when the particle is midway between its position at t equals to 2 and 3, and graph x versus t and indicate your answers graphically. So this is another physics problem, and we are given x of t, the position of the particle as a function of time. So this is 9.75 plus 1.50 t to the power 3, and this is in centimeters, remember. In part A we want to find the average velocity. So the average velocity is delta x, change in position divided by the change in time. So we want to find the average velocity between t equals to 2 seconds till t equals to 3 seconds. So the change in x will be the x at 3 seconds minus the x at 2 seconds, and that will be 3 minus 2 seconds. So the change in position divided by the change in time. Now we need to find the position of the particle at t equals to 3. So we need to put t value here in this x of t function. So we can say that x at 3 seconds is 9.75 plus 1.50, 3 to the power 3. And similarly, x at t equals to 2 seconds, we need to put t equals to 2 in that equation. So that will be 1.50 into 2 to the power 3. So let's find these values. So this gives us 50.25 centimeters. Similarly, at 2, this is 21.75 centimeter. So this is x3 and this is x2. Now plug in this equation and you will get the average velocity. Now the average velocity will be 50.25 minus 21.75 divided by the change in time, which is 1 second, 3 minus 2. So 50.25 minus 21.75 divided by 3 minus 2 gives us 28.5. So the average velocity between 2 to 3 seconds is 28.5, and the units will be centimeter per second. Now in part B, C, D, and E, we are asked to find the instantaneous velocity, and as we know that the instantaneous velocity is always equal to dx by dt. We need to take the derivative of x of t function with respect to time. So that will be the velocity. So now we need to take the derivative of this function. So the derivative of this will be, the derivative of the constant will become 0, and the derivative of this will be 3 times 1.50 t to the power 2. So this will be equal to 4.50 t square. So this is the instantaneous velocity. When the time when we decrease the time interval, and when the time interval delta t becomes very small, that the limit tends to 0, so then we get the instantaneous velocity. As we know that the instantaneous velocity, is limit t tends to 0 delta x divided by delta t, and we can replace this limit with d by dt. So if we take the derivative of the x of t function, we will get the instantaneous velocity. Now for part B, we need to find the instantaneous velocity at t equals to 2 seconds. So the instantaneous velocity at t equals to 2 seconds will be 4.50 2 to the power 2. In part C, we need to find the instantaneous velocity at t equals to 3 seconds. So the instantaneous velocity at 3 seconds is 4.50 into 3 to the power 2. 2 seconds will be 4.5 into 2 to the power 2. This is 18 centimeter per second. Similarly, for part C, that will be at 3. So this is equal to 4.50 centimeter per second. And similarly, in part D, it is said that find the instantaneous velocity at 2.50 seconds. So at 2.50. So we need to substitute t equals to 2.5. So in part D, the velocity, instantaneous velocity at 2.5 seconds is 28.125 centimeter per second. Now in part E, we are asked to find the instantaneous velocity when the particle is midway between its position at t equals to 2 and t equals to 3 seconds. So at t equals to 2, the particle is at 21.75 centimeter, and at t equals to 3, the particle is at 50.25 centimeters. So let's say that Tm is the time at which the particle is at the midway between t equals to 2 seconds and t equals to 3 seconds position. So we can find the mid position at by, we can say that the xm, the mid position, will be this x of 3, this x of 3, and this x of 2, the sum of both of these divided by 2. If we draw a horizontal line, let's say, so this is x of 2, x of 2 is 21.75 centimeter, and this is x of 3, which is 50.25. So the midway will be somewhere here. So either we can find this gap and divide it by 2, which will be x3 minus x2 divided by 2. So we will get this length, and then we will add this length to x2. So that will be xm, right? So this will be 50.25 minus x2, which is 21.75 divided by 2. So this will give us this mid length, 50.25 minus 21.75 divided by 2, which is 14.25, and then we have to add plus x2, which is 21.75. So we will get this particular position. So this particular position will be this answer plus 21.75, which is 36. So this gives us 36 centimeter. We can do the same. We can find this xm the other way around. If we add both of these and divide it by 2, we will get the mid position directly. So we will get that same 36 centimeter. So when t is tm, the particle is at 36 centimeter, the midway between t equals to 2 seconds and then t equals to 3 seconds time interval. So now we know the xm. We can write this function in terms of xm and tm. So we can write that xm is equal to 9.75 plus 1.50 into tm to the power 3. Now we can find tm if we know xm. So xm is 36 equals to 9.75 plus 1.50 tm to the power 3. So we can rearrange this and we can say that 1.50 tm to the power 3 is 36 minus 9.75. If we divide both sides by 1.50, and if we take the cube root, so we will find tm. So tm will be 36 minus 9.75 divided by 1.50. So this tm is approximately equal to 2.59. We can say that this is approximately equal to 2.60 second. Now we need to find the instantaneous velocity at tm equals to 2.60. We need to put this value in this equation. So the instantaneous velocity at Tm is 4.50 into 2.60 to the power 2. So 4.50 into 2.60 to the power 2. This gives us 30.42 centimeter per second. Now in last part of the problem, in part F, we are asked to graph x versus t and indicate our answers graphically. So I have already plotted a graph using the graphing calculator. This is x of t. We can write on the x-axis, this is t in seconds, and on the y-axis we have the x in centimeters. We can easily graph this if we plug in different values in this x of t function. We can find the x values for different t values. So let's say if we have 9.75 plus 1.5 0 into 1 to the power 3, so we will get 11.25. So at t equals to 1, the y value is 11.75, somewhere here. And let's say if we plug in 1.5, this is 1.5, so the y value is 14.81, somewhere here. And similarly, so on and so forth. We can find all these values and we can plot this graph. The average velocity from the graph is the direct line between the points on the graph. Let's say that since we want to find the average velocity between 2 and 3 seconds, so the velocity at 2 seconds is somewhere here and the velocity at 3 seconds is somewhere here. This is the velocity at 3 seconds and the velocity at 2 seconds. And if we join these 2 points, directly, so the slope of this line will give us the average velocity. So we can find the slope. We can have 2 horizontal lines like this. So now we can see that at t equals to 3, the x value is somewhere here, which is 49. We can see by eye, we can see that this is 49 centimeter. And at t equals to 2, the y value is somewhere here, which is, this is 25 and this is 20. So this is approximately, we can say 22. So this is 22 centimeter. So we can find the slope by the slope of this black line will be, this will be the rise divided by run. And the rise is the change in x. This is the rise, which is the change in x. And this is the run, which is the change in time. This is the change in time. The change in x will be this minus this. So 49 minus 22. And the change in time will be 3. This 3 minus 2. This. So 3 minus 2. So this is 49 minus 22 divided by 3 minus 2, which is 27. And from calculation, we got that average velocity is 28.5. So the value of the average velocity depends on the accuracy, that how we get the values, how accurate we get these two values by reading the graph. But the solution to part A can always be obtained like this from the graph. Similarly, for other parts, we need to draw the tangent lines at that particular points. Let's say if you want to find the instantaneous velocity at t equals to 2 seconds, we need to draw the tangent to this graph at t equals to 2 seconds. So let me draw a tangent at t equals to 2 seconds. So somewhere here is, this is t equals to 2 seconds, so we need to draw the tangent to this particular point. So let's see, let's try to draw the tangent, again the answer will depend on how accurate we draw this particular tangent line. Now this is the tangent line, and the slope of this tangent line will give us the instantaneous velocity at t equals to 2 seconds, since we have drawn this tangent to this particular graph at t equals to 2 seconds. Now we need to find the slope of this graph. So let's say if I put this horizontal line here, and let's say I put this line somewhere here, let's say. So we need to find out this value. This is at 2.75, t equals to 2.75. So this is approximately 35. And this is 1.5. So this is somewhere here, which is, we can say 12.5. So somewhere here is 12.5. This is 35. And so again, to find the tangent, we can write that to find the instantaneous velocity at t equals to 2 seconds, we need to find the slope of the black line, which is the rise divided by run. Now this is the rise from here to here. This is the rise, which is 35 minus 12.5. So 35 minus 12.5 divided by the runs. So the run will be from 2.75 to here. Since we are reading the values for 2.75 and 1.5. So 2.75 minus 1.5. So 2.75 minus 1.5. So 35 minus 12.5 divided by 2.75 minus 1.5. This gives us exactly 18. So the instantaneous velocity at t equals to 2 seconds was 18 centimeter per second, and we got that same value by finding the slope of the tangent line drawn to x of t graph at t equals to 2 seconds. And similarly, you guys can find the instantaneous velocity for other parts of the problem using the tangent line method, using this graph. So if you want to find the instantaneous velocity at t equals to 3 seconds, we need to draw this tangent at t equals to 3 seconds, and then we need to find the slope of that particular line, and then we will get the instantaneous velocity at t equals to 3 seconds. So this is the solution of this particular problem. I hope you people will be able to find the instantaneous velocity for a given function using the derivative method and using the graph as well.